Hello, this is Britt Caswell with another video on multiplying binomials. The method I'm covering in this video is called the distribution method, which is also sometimes called foiling. I don't like using the term foiling because that's restricted to binomials. However, this multiplication process can work for any type of polynomial. So the way that you approach this method is you take each term within the first set of parentheses and you multiply them to each term within the second set of parentheses. So on this first example, I'm going to take this starting x value and I will multiply it to the x in the second parenthesis and to the 3. So x times x gives me x squared, and x times 3 gives me 3x. So once you've multiplied the first term, then I just go systematically now to the next term. So I will take this 2 and also multiply it to the x and the 3 in the second set of parentheses. So I get 2 times x, which is 2x, and 2 times 3, which is 6. Our last step for this is to, of course, collect our like terms, which will usually appear here in the middle, as long as your expression is written in what's called standard form, where you have a variable going down by power and then the constant. So I have an x squared, and then 3x plus 2x is a total of 5x, and then a plus 6. And that gets me my final answer. Here we are with our second example. I'm going to describe it now with the idea of foiling. So what foiling stands for is first, outer, inner, last. So what it does is it explains to you the order of steps that we need to multiply with. So I'm going to start with the first here in orange. So that's saying that I'm going to take the first two terms in the expression and multiply them together. So x times x gives me x squared. The O stands for the outer terms. So I'm taking the ones that are on the outside of the expression. So I have an x and a negative 7, which when multiplied together makes negative 7x. If you notice, all that I did really with this first two steps was I took x and times it to each of the terms, which is what I explained earlier. The next one is inner. So that's saying that I'm going to take the inner two terms and multiply them together. So negative 1 times x is negative 1x, or just negative x. And then the L stands for the last two terms. So you take the last term in each set of parentheses and multiply them together. So I'd be taking negative 1 and multiplying it to negative 7, which is a total of positive 7, which in terms of my last example is like the 2 distributing to each term. I took negative 1 and distributed it. Then we go through and we collect our like terms, which you see here. So I have x squared, negative 7x minus x is negative 8x plus 7. And that is my final solution there. On my next example, I'm going back to just talking about distribution, as I think that's easier to see. So the example gets a little more complex because now I have values in front of the x. But it still works the same way. I'm going to multiply together the coefficients and add their exponents. So we'll be taking 2x and timesing it to the 3x, and then I'll times it to the negative 1. So 2x times 3x is 6x squared, and 2x times negative 1 is negative 2x. So then I'm going to go through and take the positive 1 here, and I'm going to distribute it as well. Now remember, 1 times anything is whatever that is. So since I'm multiplying 1 to the second set of parentheses, it'll just look the exact same as 3x minus 1. Now we go through, we do our collection of like terms right here in the middle. So I have 6x squared. Oh, I don't know why that happened. But a 6x squared. And then negative 2x plus 3x is a positive 1x. And then my minus 1 falls down, giving me my final solution. Now this final example is an example of something called conjugates. In my last video, I explained briefly that conjugates are terms or expressions that basically match each other, except the middle sign is flipped. When you have a conjugate, it creates a pattern which we will be using later in factoring. So it's nice when you're just starting out to look to see when this pattern's happening. So I'll start with this 3x and multiply it again to each term in the second set of parentheses. So 3x times 3x is 9x squared, and 3x times negative 2 is negative 6x. Then I move over here to my second value. I have a 2. So when I multiply it to each term, 2 times 3x is a positive 6x, and 2 times negative 2 is negative 4. So if we look at our expression that we would simplify, and we go to collect these like terms, we have to think about what happens when you subtract a something and add that same value. They cancel each other out. So this expression doesn't turn into a trinomial at all in the end. It just turns into a binomial, which appears as if you just multiply the first two terms and you multiply the last two terms and put them together. Because of this pattern, many students make mistakes, which I call the freshman dream. The freshman dream is when you multiply together the first two terms and the last two terms, and you pretend like those middle terms cancel out. So if I had just done the freshman dream on this example here, I would have gotten 6x squared minus 1, which if you notice is missing that x term. So make sure with this concept of conjugates that if you're multiplying the first two and the last two only, you have a true pair of conjugates, which is the same term, one with a plus, one with a minus. Alrighty, so that is all of the examples I have for the distribution method. In my next video, I will start covering more examples of conjugates called a difference of squares. Until next time.